Here's another system of equations problem involving digit reversal. So it says the sum of the digits of a certain two-digit number is 9. So we know that if we had a two-digit number and I put x in the tens place and y in the ones place, they don't necessarily have to be the same. They could be. In this case, they probably aren't because the sum is odd. Okay, but I know now that if I add the x and the y, I'm going to get 9. So I've got one of my two equations. Now I need another. It's a little trickier, but we know that since this is the tens place and this is the ones place, right, the value of that number is 10x plus 1y. For example, if it was 36, and I don't know if that's the right answer, probably not, right? The 3 represents how many tens, and the 6 represents how many ones, so it's 36, right? And I'm just going to use this expression to get that result, to get the value. And that's going to come into play. But we also are going to reverse the digits, and if I reverse the digits, now the y is in the tens place, and the x is in the ones place. Okay, and it forms some sort of relationship, and it's kind of telling us what's happening here. So I know that there's a relationship between the value of the original number and the value if I switch the digits. They're not equal. When you reverse the digits, you decrease the number by 81. So this number is 81 smaller than this number. So I either have to add 81 here or subtract 81 here. I like adding the 81. So I get this expression, which I'm going to bring this a little closer so it kind of looks more like an equation. Right? And I'm going to manipulate that until I get something in standard form. So to do that, I'm going to subtract 10y from both sides. At the same time, I'm sorry, that's supposed to be an x here. This is an x. At the same time, I'm going to subtract 1x from both sides. This side, everything except for the 81 cancels. This side, I get 9x minus 9y. And there is my second equation. So 9x minus 9y equals 81. And once I have my system, I could solve it any way I choose. Now, with this type of problem, I noticed that I can, instead of multiplying the top equation, I notice that the bottom equation is divisible by 9. So I'm going to divide everything by 9 in the bottom equation. I'm going to keep the top equation exactly the way it is. And if I divide this by 9, I get x subtract y equals 9. So, how do I solve this system? Well, let's add the two equations together to get 2x, the y's cancel, equals 18, and divide by 2. In that case, x is equal to 9. Now, let's use that information and plug in 9 here. 9 plus what is equal to 9? That means that y must equal 0. 9 plus y equals 9, subtract 9, and y equals 0. Does this work for our problem? Well, definitely 9 plus 0 satisfies that equation. And how about 9 here and 0 here? 9 times 9 would be 81. 9 times 0 would be 0. And 81 minus 0 is 81. So there's my solution. The original number is 90. Flip it around, 0, 9. And yes, they have a sum, which is 9. And when you reverse it, it decreases.